So now we're putting all these forms together in the word problem. So if you remember the word problems, 3 key things we're looking for. Y-intercept, vertex, is that maximum or minimum. Y-intercept, remember, is the start. And then also we have the x-intercept, which is the ending value. So standard form, factored form, vertex form, we're going to be putting it all together now. So standard form highlights the y-intercept. Factored form highlights the x-intercepts, that ending value, right? And then the vertex form highlights that vertex, that max or min. So they're going to be asking for one of these forms within the problem. So let's look at this first question. Jessie tossed a paintbrush off of the roof, and you can kind of see that in this graph, tossing the paintbrush off the roof. And she wants to know when the brush will hit the ground. So that would be right here. Toss it off the roof, boom, hits the ground. So that being the x-intercept means that we're going to be using factored form. That's what highlights those x-intercepts, right? So let's go ahead and factor it. And that's actually one of the easier methods. That's one of our preferred methods, right? Just a factor. So we're going to start by factoring out that -5 in the front. So it's going to be -5 and then t squared minus t minus 2. And then let's go ahead and use that diamond method. What multiplies -2 and adds -1 would be -2 and +1. So we'll have t minus 2, t plus 1. And that's what h of t is. That's our factored form. So how do we use that to solve the problem? Well, when it hits the ground is when our height is 0. So we set our height equal to 0. Keep this the same. And our time would be 2 and -1. Now we're not going to use negative time. We're not going to go back in time. So time equal to 2 will be our answer. And that's it. That's how you do that one. Let's take a look at one that's using that vertex form. So Paul wants to know what his bakery's lowest net value will be. Now net value, that's going to be the y value. The y value of the vertex. How do we know this? Because it's asking for the actual lowest value. It's not asking what's going to cause it to happen. And what I mean by that is t would be the x value, would be the input value, right? So t months, if it is asking how many months will it be before it reaches the lowest value, then it's asking for that x value. But here it's just straight up asking what's that lowest point. So that's that vertex, right? And not just the x coordinate, but the y coordinate. So they want us to get into vertex form. I know there's a shortcut to get the vertex, but they're forcing us to take the route of getting vertex form. So currently we have v of t equals 2t squared minus 12t minus 14. And I'm going to factor out the 2. And then we're going to complete the square. So we're going to use that whole method. So we have -6. We want both factors to be the same, so divide that by 2, multiply them to get our special value of 9. And then these 3 right here are going to be our perfect square. And you can see the factoring here, right? This would be what multiplies 9 adds -6. -3 and -3. So since we have it twice, we're going to have it squared. The -9 minus 7 is -16. Here's the 2. So we're going to go ahead and distribute that 2 to both of these and get 2 times t minus 3 squared minus 32. If I can write it too. That's good enough. So there's our vertex form. And that's the appropriate way to do it. I know there are some shortcut methods. If you prefer one of those, that's fine. So what's the lowest net value? So we know it shifts to the right 3. So our vertex to the right 3 and then down 32. So the actual lowest value is -32. When it occurs is 3 months. This last one's very similar. They just want to know when the hovercraft. So this would be that x value that you would get from doing this. But same idea. When will it reach the highest point? So looking for the vertex, but this time we just want that x value.